All right, welcome to the Explainer. We love tackling big topics here, but today we're going small. I mean, really small. We're going to talk about the most basic, the most common, and you could definitely argue the most important element out there, hydrogen.
So let me just kick things off with a question for you. Think about, well, everything. The stars, the planets, you, me. What do you think is the single most common ingredient in the entire universe? The one thing that makes up more of everything than anything else? The answer? Well, it might not be what you think.
Yep, you guessed it, or maybe you didn't. It's hydrogen. This is it, the universe's #1 building block. It's the simplest, most plentiful element there is, and believe me, it has an absolutely epic story.
Okay, so let's properly meet our hero for this explainer. To really get why this tiny little atom is such a big deal, why it's #1, we've got to start with the absolute basics. What makes it tick?
It really all boils down to its structure. A regular old hydrogen atom is, well, about as simple as you can get. It's just one proton in the center with a positive charge and one electron with a negative charge kind of whizzing around it. Seriously, that's it. And that beautiful simplicity, that's why it gets the #1 spot on the periodic table.
Okay, now the sheer scale of hydrogen's dominance, it's honestly kind of hard to wrap your head around. We're talking about 75% of all the known matter in the entire universe. Think about that. The stars, those giant gas planets like Jupiter, even those huge, empty-looking clouds between galaxies, it's pretty much all hydrogen.
But here's a cool thing. Not all hydrogen is exactly the same. It's kind of like a family. You've got the original, protium, the one we just met. But every once in a while, a hydrogen atom will, put on a neutron backpack. If it picks up one neutron, we call it deuterium. It's a bit of a heavyweight. If it picks up two, you get tritium, which is super rare and radioactive. But they're all still hydrogen, right? Because they all have that one proton. The extra neutrons just change their weight and what they can do.
So we know what it is now, but how in the world did we find it in the first place? I mean, it's an invisible gas. The story of how we finally met hydrogen is this amazing scientific adventure, a real detective story that took centuries to solve. The first clues actually popped up way back in the 1500s. Alchemists were messing around, and they noticed that when they mixed certain metals and acids, this weird flammable gas would bubble up, but nobody really knew what it was. Fast forward to 1766, and this brilliant scientist, Henry Cavendish, he finally manages to capture this inflammable air and proves it's its own unique thing. And then, a few years later, he has his real aha moment. He burns the gas and discovers that it creates water. Just pure water. That one discovery, burning this gas makes water, was a total game changer. It led another amazing chemist, Antoine Lavoisier, to give the element its name. He took the Greek word for water, which is hydro, and the Greek word for maker, which is genes, and he smushed them together. So hydrogen literally just means water maker. How cool is that?
Okay, so knowing its history is one thing, but now for the really fun part, seeing what this stuff can actually do. So let's get our hands a little dirty, metaphorically speaking, and check out some of hydrogen's amazing superpowers.
Remember how its name means water maker? Well, it turns out we can also be water splitters. There's this process called electrolysis, which sounds complicated, but it's not. You just run a little electricity through water, and it literally breaks it back apart into its two ingredients. You'll see these little bubbles start to form, and since water, H2O, has 2 hydrogen atoms for every 1 oxygen, you actually collect twice as much hydrogen gas as you do oxygen.
Right, so picture this. You've got a test tube full of this gas. You can't see it, you can't smell it. How on earth do you know for a fact that it's hydrogen? How do you prove it's not just, plain old air?
Well, there's a test for that, and it goes pop. It's the famous squeaky pop test. You take a lit match or a glowing splint, bring it right to the top of the test tube, and if it's hydrogen, whoop, it reacts with the oxygen in the air and makes the super distinctive pop sound. It is a total chemistry classic.
Now that fiery pop isn't hydrogen's only superpower. It's also crazy light. I mean, it's the lightest gas in existence, something like 14 times lighter than the air we're breathing right now. It's why if you fill a balloon with it, it doesn't just kind of float up, it rockets to the ceiling. And that combo, being super light but also super flammable, is exactly why people started using it in those early giant airships. But you have to respect that fiery side. The Hindenburg disaster was, of course, a terrible, tragic lesson in just how flammable hydrogen is. And that's exactly why modern blimps use helium instead. It's still super light, but it won't burn. Okay, so let's pull way, way back now. I want you to zoom out from our little planet and look up at the night sky. Because as important as hydrogen is here, its biggest, most important job is out there. It's in the stars. Yeah, every single star you can see, and that includes our very own sun, is basically just a giant fiery ball of hydrogen gas. The light that you see, the heat that you feel, all the things that make life on this planet possible, it all comes from the insane amount of power that's locked inside that tiny little atom. So how do they do it? How do stars generate all that energy? The secret is something called nuclear fusion. Deep inside a star's core, the gravity is so immense, so crushing, that it literally squeezes hydrogen atoms together until they fuse and become helium. And when that happens, boom, it releases a mind-boggling amount of energy. That's sunlight. That's what we feel on our faces every day. So think about that. It powers the stars, and it could potentially power our world. Hydrogen's story is absolutely not over, so let's bring it all back home, back to Earth, and see what its mission is right here, right now, and for our future. You know, you probably don't even realize it, but hydrogen is already working behind the scenes all around us. It's this quiet workhorse. It's a key ingredient in making fertilizer to grow our food. It's used to refine gasoline. And of course, it's the incredibly powerful stuff we use for rocket fuel to send us to space. Okay, so when we start talking about hydrogen as the fuel of the future, there's something really important you have to know. Not all hydrogen is made the same way. We actually talk about it in colors. Most of what we use today is gray hydrogen, which comes from natural gas and, well, it releases CO2. Then there's blue hydrogen, which is the same idea, but they try to capture that CO2. But the real hero, the one we're all aiming for, is green hydrogen. That's when you use clean, renewable energy, like solar or wind, to do that water-splitting trick we talked about. The result? Zero carbon footprint. The big challenge is just figuring out how to make it cheap enough and on a massive scale. So how would this actually power a car? Well, it uses something called a fuel cell, which is basically like running that water-splitting experiment, but in reverse. It takes hydrogen fuel, mixes it with oxygen from the air, and through a neat chemical reaction, it creates electricity to make the car go. And here's the best part, the really amazing part. The only thing that comes out of the exhaust pipe is water. That's it, just clean water. All right, that was a lot to take in. So let's do a quick recap. What are the big things to remember about hydrogen? Number 1, it's the simplest and most abundant thing in the whole universe. Number 2, its name means water maker. 3, it's the fuel that makes the stars shine. 4, it's that super light gas that gives you that classic pop. And finally, number 5, green hydrogen just might be a huge part of a clean energy future for all of us. And that really brings us to the big final question, doesn't it? We've seen this tiny atom build the entire cosmos and fuel every star. So now, as we're all looking for clean ways to power our lives here on Earth, could this little element, number 1 on the charts, turn out to be our biggest hero of all?